Hello everyone and welcome to the PyListnik channel. Today we're going to talk about something you use literally every single second you're online, but probably never even think about. It's called the MAC address, and you can think of it as the secret permanent ID card for every single one of your connected devices. So how does this secret identity actually work? Let's find out.
Okay, just picture this for a second. It's a busy evening at home. The TV is streaming a movie on Netflix, your laptop is downloading some huge work files, and your phone is just endlessly scrolling through social media. They're all connected to the same Wi-Fi. So how in the world does your router know to send the movie to the TV and not accidentally beam it over to your work laptop? Well, the answer is a hidden digital fingerprint.
And here it is, the hero of our story, the MAC address, which stands for Media Access Control. It's this totally unique serial number that is physically, and I mean literally, burned into the network hardware of your device. Your phone, your TV, your computer, they all have one. It is the device's permanent, unchangeable fingerprint, and it's exactly how your router can tell all your gadgets apart on your home network.
Now I know what you're probably thinking. Hang on, I thought my device had an IP address? And you're absolutely right, it does. But here's the thing. To make the internet work seamlessly, networks actually need two different kinds of addresses working together in perfect harmony. So let's explore this crucial partnership between a MAC address and an IP address.
You know, the easiest way to think about this is with a simple analogy. Your IP address is like the mailing address for your house. It tells the global internet where to send data, and it can change if you say, take your laptop to a coffee shop. The MAC address, though, that's like your actual name. It identifies you, specifically, inside that house. It's permanent. It identifies the device itself, not just where it happens to be at the moment.
So let's go back to that movie night. When you hit play, the IP address acts like a global GPS, guiding all those little data packets from Netflix's servers across the entire internet right to your front door, which is your router. As soon as that data arrives, your router checks the local delivery instructions and says, aha, this packet is for the TV, and then it uses the TV's unique MAC address to hand it off to the right screen. Simple as that. Okay, so let's dig a little deeper now and see how this digital fingerprint is actually put together. Because it's not just a random string of characters. There's a really cool logic behind it.
So here's what a typical MAC address looks like. It's a 48-bit number, but to make it readable for us humans, it's shown as 12 hexadecimal digits. That's just a fancy way of saying it uses numbers from 0 to 9 and letters from A to F. And you'll usually see them broken up into 6 pairs. At first glance, yeah, it just looks like a bunch of code, but it's actually telling a story.
See, this address is split into two parts. The first half is called the Organizationally Unique Identifier, or OUI. This block of characters is assigned by a standards organization to a specific manufacturer, like Apple or Intel or Samsung. So just by looking at the first 6 digits, you can tell who made the networking chip. The second half is the unique serial number that the manufacturer assigned to that one single specific device. No two are alike.
So the big question is, how many unique addresses can this system create? Get ready for this. Over 281 trillion. That is an absolutely astronomical number. It's why, for decades, we haven't even come close to running out of unique IDs for every single phone, computer, and smart toaster being made.
Now, here's where the story takes a fascinating twist. I've been saying these addresses are permanent and burned in, and for a very long time that was the absolute truth. But, you know, in our modern privacy-focused world, that's not quite the whole story anymore.
For decades, this was the core concept. The MAC address was known as a BIA, a burned-in address. The idea was that it was physically part of the hardware, it was unchangeable, and that was that. It was the one, true, reliable identifier for a device. Which, of course, raises a really important question. If it's physically burned into the chip, why do our iPhones, our Android phones, and our Windows laptops all have a setting to use randomized hardware addresses or a private Wi-Fi address? How can you change something that's supposed to be permanent?
The answer all comes down to one word: privacy. Think about it. If your phone used its real, unchanging MAC address at the airport, and then at a coffee shop, and then at the mall, companies could use that unique identifier to build a map of your physical movements. To stop this, modern operating systems now create a fake, temporary MAC address every time you connect to a new public network. It's like giving your device a new disguise for every place it visits.
This act of changing a MAC address has a technical name:
Mac spoofing. And while our phones and computers do it automatically for our own privacy, it's a technique that can also be used for malicious reasons. An attacker could spoof their MAC address to impersonate a trusted device on a network, which could let them snoop on data or get access they shouldn't have.
Okay, so let's wrap this up with something you can actually use. How does this all apply to you? How can you find your device's MAC address and maybe even use it to make your own home network a little more secure?
One of the most common ways to use this is something called MAC filtering. You can actually log into your Wi-Fi router's settings and create what's called an access control list. Basically, you're creating an exclusive guest list for your network. You can tell your router to only allow devices with these specific MAC addresses to connect. It's like having a bouncer for your Wi-Fi.
And if you want to set that up, you're going to need to find your device's MAC address, which is often called the physical address in your system settings. It's really easy. On Windows, you just open a command prompt and type ipconfig/all. On a Mac, you'll find it in your network settings. And on Linux, you can use the command ipadd-show.
And all of this leaves us with a really fascinating final thought. The very thing that makes a MAC address such a great feature for security, the fact that it's permanent and unique, is also what makes it a potential bug for our privacy. This tension between being identified for security and being anonymous for privacy is at the very heart of our digital lives today. It really makes you wonder which one we value more. Thanks for diving into this with me.